Hello and welcome to T2 Day 29 of Honors Precalculus. Today we're going to talk about another polar function type called Limacon curves. So we're going to graph these by first drawing the Cartesian cousin, I guess is what we're going to call it. I like that, of the polar graph. So we're going to plot out the points in the Cartesian plane and then plot them on the polar set of axes. So what happens here is we just need to plug in theta values into here and get out r values. So for example, when you plug in 0, cosine of 0 is 1, 1 times 2 is 2, 2 plus 2 is 4. So this starts right here. And then if you graph it out, it's at pi, it's going to be down at 0, and it's going to go back up. The period is going to be 2 pi, so it actually halfway through here. So this is very similar to something we've done before, where you draw these points in that are there, and then you draw in the curve. There you go. Remember, there's like that midline at y equals 2, or in this case, r equals 2. It's right in the middle there because of that too. So this is what it looks like in Cartesian. Remember, this is theta and this is r. When we now can graph with this data what it looks like in polar form. So you have to do this really carefully. So remember, your points are all r comma theta. And I think I made a mistake in the last video that some of you might have caught where I flipped maybe one or two of the points. It was r comma theta. So if we list out the points, for example, this point right here, that point right there was r value of 4 and a theta value of 0. So that's going to start right here, 4, 0. And then the next point, for example, it's at 2 pi over 2. So when this was pi over 2, which is right here, here's that second point. This second point, we'll call that point A. Point A is r value of 2 and at pi over 2. So what's that angle value going to be? That's right here. Pi over 2 is right here. So there's your point A. And then you could do we'll call that point B right there. That's the 0 comma pi. When you had a theta value of pi, r was 0. So what does this actually look like when you graph it out? If you graph more, even more finely, it looks like this. Kind of goes like that. And then if you graph the rest of the points, it's actually going to get, it crosses down here. It's going to be a reflection, and then it's going to be like this. So this curve is actually a little higher. It goes up a little bit higher like this. But you know that because if you plot these points out, and if you list them all out from the graph, you get a couple more points, and you end up with this cardioid. That's what this shape is called. It looks like a heart. So let's do the same thing, but for r equals 3 minus 4 sine 0. We know the midline is going to be at 3, and it's going to go down 4. So what it's going to do is it's going to go down to here. It's going to go down 4. There's negative 1 right there. And then it goes back up to the midline, and then it goes up again all the way up to here, and then it goes back down to 2 pi. So when you graph this, you end up with this curve right here. And what you can do is you can take these points right here. These have an r value and a theta value. Remember, it's theta going this way and r going up like this. You can list out those points. If you list out those points, remember, it goes r comma theta. The first one, you have 3, 0. When theta was 0, r was 3. Then you had negative 1 pi over 2. And the rest of them are those points. So what you do is you graph these out. You end up with 3, 0 right here. Negative 1 pi over 2. Negative 1 pi over 2. Remember, the way you do that is you go to 1. So you go to 1 pi over 2. And then you flip it. So remember, that means it's going to go down to here. So when you plot out those 4 points, you end up with these intersections right here. So one thing you can do here is plot even more points. You can go in between. You could use your calculator to plot the sine and cosine values. So what you end up with is you end up with a curve. When you connect these, you end up with a curve that started here, and it goes around. It actually does this really cool thing. It goes through here, goes back up, and then it goes down. It's pretty cool, and it's symmetric. So I'll get better, and you will too, of graphing these, but they have this nice symmetry to them, and there actually is this little hole in the middle here. So if you just draw 4 points, you can't really see it, but you can connect them with these arcs, and that's how it'll work. And then you also might be interested in that it does cross the origin right there, and that's because it's crossing here. That's where the pole crosses the poles. So you can kind of think like the little loop happens because of that. The loop happens because it crosses there, and it crosses there, crosses the theta axis. R is 0 there. So what you'll have in the rest of the sheet is you'll have the Cartesian cousin graph, and then you can use the data you get to make the graph on the polar graph. So you have a few more examples here, but what you really should be investigating right here is what this family of equations breaks down to. These are different kinds of Limacon curves because they're of this family. R equals a plus or minus b cosine theta, and R equals a plus or minus b sine theta. Try seeing what happens when a and b are different values. Use Desmos to investigate. Use Desmos to investigate. It's going to be super cool. Make sliders, and I can show you that in class.